Suppose you drive an average of 10,000 miles each year. Your gas mileage, miles per gallon, that's how they say gas mileage, varies inversely with the number of gallons of gas you use each year. Write a model for your average mileage P in terms of gallons G of gas being used, then graph the model. Okay, so inversely is key here. So you go P equals, that's your dependent variable, and then the other variable is in a fraction with the denominator. Okay, now let me explain why this is rather than just telling you. Okay, P is your average mileage. Okay, that's expressed as miles per gallon. That's how mileage is expressed, miles per gallon. Just put miles over gallon. Now there's the G on the bottom. Now the miles, okay, we don't need M because we have a set amount of miles that we are driving, 10,000. Okay, so this is going to be an inverse function because as the G grows, okay, as a G grows, then the P shrinks. As a G gets smaller, then I'm dividing 10,000 by a smaller number and the P would grow. That's why it's inverse. It's also a rational function because we have that variable G in the denominator. Okay, so we need to know what our asymptotes are. Asymptotes. Now, G is where the X was in the last assignment, and then P is where the Y was. So on G, remember, the whole idea, you set that equal to 0. Remember, the asymptote is what your G will never get to. Okay, so you put G equals 0, so I guess it's 0. Okay, so on the G axis, so I'm going across here, 0. Remember, that is a straight vertical line. Okay, I'm going to go up a little ways and put G equals 0. I know that's the p-axis, but remember the asymptote's opposite. Now the p-asymptote, just pick an insanely high input for your G, 200,000. So P equals 10,000 divided by 200,000. Now we want to see what that's really close to. Don't put the exact answer. Looks like it's pretty close to 0. Okay. So now, on my P, I go find 0, and that one's straight across. Okay, so really it's just the axis themselves I'm tracing over. Okay, now a story problem, we're just going to go to the right. Okay, and we are going to go to the right of G equals 0. Okay, but I'm going to pick 3 coordinates instead of 2. We don't need left. There is no left of G. It's a story problem because left of G takes you into the negatives. Okay, which we don't want. So G and P, not X, Y. So I go 3 to the right of G equals 0. Let's go, don't go 1, 2 though. Go 50, 100, 150. Okay, now I'll substitute those in and get my output. So P equals 10,000 divided by 50. So 10,000 divided by 50, that's going to be 200. Okay, so if G is 50, P is 200. Now I will put 100. Okay, so P is equal to 10,000 divided by 100. Okay, that was just by chance. Now I put 150. Okay, 66.67. So as you can see, as the G increases, then the P decreases. That's why it's a rational function. Okay, so that would be right in here. Okay, so there's the graph. Okay, now in the next problem, we're going to put something new to our function. Okay. when you drive on the highway more often, you use 50 gallons less per year. Write and graph a new model. So it's next year, but now I drove on the highway more often, so then the gallons I had to use of gas decreases. But I still did 10,000 miles. Okay, so I use that same equation. P equals 10,000 divided by G. I just take my gallons G and minus 50 from it. Okay. Now, asymptotes. There's G and there's P. Now the G isn't going to be 0 anymore. Okay. So I would take that G minus 50, set it equal to 0. Now the reason the asymptotes shift in the context of a real life problem, so 50 is your asymptote, there's no way you got less than 50 gallons of gas, okay, because you did 50 less, okay, so I mean, doesn't make any sense to have 25 gallons but 50 gallons less, okay, so G is 50, so I go here, and now there's my new vertical asymptote, okay. This is G, this is P, okay? So, G equals 50. Now to find P, take your 200,000. So P equals 10,000 divided by 200,000 minus 50. So 200,000 minus 50, it's going to be 199,950. Okay, that's approximately 0. Okay, so that P is still gonna, the horizontal asymptote still remains the same. Okay, now when I do my 3 points to right, I don't go left on a story problem. Okay, set up your 3 GP coordinates. And now we're going to go to the right of G equals 50. Okay. Because negatives aren't going to make sense. If you go anything that way, you're going to that minus 50 is negative, which doesn't make any sense. So that's why it's shifted. So we'll go 100, 150, 200. You can pick any ones you want as long as they're to the right of 50. Okay, so I put 100 in. So P equals 10,000, and then 100 minus 50. Well, that's 50. And then 10,000 divided by 50 is going to be 200. So the input of 100 gave me 200. 100, 200. Okay, now I substitute 150 for G. That's going to be 100. Now we divide 10,000 by 100, and that's actually 100. Okay, then 200. That's 150. Okay, 66.67. So now 200, 66.67. So essentially it's the same thing as the last one, just everything shoved 50 units over. Okay, now part C. Okay. Calculate your old and new mileage, assuming you originally used 400 gallons of gasoline per year. Okay, so I go to part A and write that function down, what I wrote. That's just P equals 10,000 divided by G. I'm not going to really look at the graphs. You could, but the graphs aren't very accurate. Okay, and then I'm going to write my B equation, okay, for part B, 10,000 over G minus 50. P equals 10,000 divided by G minus 50. Okay. 400 gallons of gas. Set up GP coordinates on both of them. Okay, GP. Well, what that means is 400 gallons, so 400 gallons. Now substitute 400 in for G in each one. So P equals 10,000 divided by 400. Okay. So 10,000 divided by 400, and that's going to be 25. So 25 miles per gallon there. Okay. That's the old mileage. Just put M miles per gallon. Okay, now substitute 400 here. So P equals 10,000, then 400 minus 50, that's going to be 350. Then you divide 10,000 by 350, 28.57. Makes sense because when I'm using less gas mileage, when I'm using less gallons, okay, then the miles per gallon, the P goes up, okay.